Good evening, everyone.
Good evening.
Good evening. So, how are you all? All good? Not many people
Ma'am,
have
going
come.
on.
Huh?
Ma'am, going on.
Going on. The Sunday you all have exams, right?
Yes, ma'am. Yes, me
Yeah.
too.
So preparing in that tension, right? All of you are in that tension.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
So, how is the preparation going on?
बढ़िया मैम अच्छा ही चल
Huh?
रहा
It's going.
अच्छा चल रहा है
Okay. So, in today's session, we are going to take doubts of 8. So, have you gone through week 8 now?
Yes, ma'am.
Yes. Okay. So, let's go by activity wise. Okay.
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 Yes, ma'am.
Okay. In the last session, there was one doubt from week 7 graded assignment. Is that person here? I don't know his name. I don't remember him. But is he here? I don't know. Okay, let's take it to the last step. Okay. Now, for activity 8.1, anyone having any doubts?
No, ma'am.
No? Okay. Then activity 8.2. Have you guys done the activity questions?
Ma'am, actually, I have done the non-graded assignment, practice assignment, and the graded one directly.
Non-graded. Okay, so you have not done the
Practice one.
activity? Okay. So, okay, what about others?
Ma'am, done the activity questions.
Okay, so no doubts in activity questions? Anyone? There are 17 people here. At least I need answers from 10 people. What about the others?
Done the assignment.
Sorry?
I have completed them. I'm going through them. If I have any questions,
Okay,
I will ask.
okay, okay.
Ma'am,
Then what
can you
about
more
others?
clarify, like which face cards, like how many face cards do we have in one, like 13 particular things, like cards?
Face cards. Like
Yes,
in
yes,
total from 50, huh?
yes, ma'am. Face cards, like I think King, Queen, Jack, and one more was there.
So basically we have King, Queen, Jack. No, only three are there, no? Three in the sense, see, we have like we have total we have 52 cards, right? In that 52 cards we have four colors, right? Four different shapes. So
Yes, ma'am.
two one is heart, one is spade. Okay, let's do red then. So one is diamond, one is spade, one is flower, right? So these are all red color and these are all black color, correct? Now in
Yes.
each of these faces we have three face card, which is king, queen, and jack. Similarly, this three, and this three. So in total we have how many cards? 12 face cards. Okay.
And ma'am, what is the ace?
Ace is not a face card, it is just a different card, you can say that. Ace is
Oh,
just a number, or you can say which denote one. Right?
the number cards, right?
Now, it can't be included in number also. It depends upon the question. If they are taking, so normally we say the number cards are like 2 to 10. Okay. Then we have ace, then we have the face cards like that.
Oh, okay, yes.
Okay. And
Okay,
if they include ace as a number card, they will specify it in the question. Okay.
okay, ma'am. So that means each and every group of cards, like the four groups, so each of them have one ace of their own, right?
Correct.
Okay, understood.
Okay. Okay. What about others? No doubt in activity question, that means No one is having any doubts from activity questions.
Ma'am, I have doubt in 8.5.
8.5. Okay, which question?
Question 3 and 4.
Suppose for the probability of flight being delayed is this. Find the probability of no delays on a round trip. No delays is anything. Concept analysis. No, it's a simple question. See, they are saying that the probability of getting delays, the flight will get delayed, is 0.4, correct?
Yes, ma'am.
Right? Now they are asking what is the find the probability of no delays on a round trip. So first of all, probability of no delay will be what? 1 minus probability of delay. Yes.
Yes, ma'am.
Okay. So this will be what? 1 minus 0.4, which is 0.6, correct? So probability of the flight not getting delayed is actually my 0.6 probability. Now they are saying that on a round trip means like there are the see one is A, one place is A and B. Say destination is B. So from A to B and then coming back to B to A. So this is my one round trip, correct?
Yes, ma'am.
So for this, for one trip, the probability of not getting delay is 0.6. Similarly, from coming back, so we have two ways, right? So this also was 0.6. So in total, we have 0.6 into 0.6, which is
0.36.
okay.
Yes, ma'am.
Then a dice thrown twice, what is the probability that both the outcomes are prime number? Okay. So the die is thrown twice. So okay, can you tell me what are my prime numbers?
2, 3, and 5.
2, 3, and 5. So I need to know that both the outcomes are my prime numbers. Okay. So it can be 2 comma 2, right? Then 2 comma 3, then 2 comma 5. Then what are my possible outcomes?
5 comma 2.
Hmm.
Yeah. 3
3,
comma
comma
5.
2.
Huh?
3 comma 5.
3, comma 5 and 5, comma 3.
Okay.
3 के लिए maximum 6 ही probability I think.
What?
I'm saying
3,
for
2
3 I
also.
think maximum probability 6. अच्छा.
So 2 comma 2, 2 comma 3, 2 comma 5, 5 comma 2, 2 comma 5. Yes. Then we can have 3 comma 3 as well. Then we can have 5 comma 5 as well. Then uh,
3, 2.
3 comma 2. Have I left anything?
Yeah, total 9.
Okay. So in total, I have 9. Okay. So what is the probability? It will be 9 by,
9 by 36.
and this will be
1 by 4.
3.
0.25,
Yes.
right? Is it fine?
Yes, ma'am.
Okay. Is this question clear? 3 and 4?
Yes, ma'am. Ma'am,
Okay.
can
Huh.
you tell the question number 4 of activity 8.7?
Question number?
Question number 4 of 8.7 activity.
Task is given which needs to be done.
Ma'am, you did 0.6 into 0.6 for that previous question.
Ah,
Oh, okay. Yes, understood. Okay.
if the probability of completing the task is there, the task is being done. The probability is
Ma'am, which question is this? Which activity question?
question number 4.
Okay.
It's question 4 of activity 8.7.
Okay, thank you. Ma'am, can we say here that like there are 3%, so one person complete, other two do not complete. Again, second person completes, other two do not complete, and again third one completes, other two do not complete, and then
Easier, it's easier to do with complement. Use complement of all three. That is, nobody completes, and then take complement of the product.
yeah, that way we get the same answer, right?
Yeah, it's faster, no, because you don't have to make cases then. Just need one case.
Yes,
And
yes,
nobody
yes.
completes is one case.
Yeah, yeah.
Ma'am, are you speaking? I think you aren't audible.
No, I'm not speaking.
Okay.
Yeah, so okay, so they are saying that probability of completing by is 1 by 2. Task is complete. Okay, so the thing is, they're not said any equally likely. Okay, so we will go with that. Okay, so we will take the complement of this. This is 1 by 2. This is 3 by 4.
7 by
This is 7 by 8. Okay, so like uh, they have not completed. It will be 1 by 2 plus 3 by 4 plus 7 by 8. What is this total?
multiplied, ma'am. Okay. Multiplied. All three will not complete.
Yeah, it should be multiplied. Hmm? Hmm. Give me a minute. Just a second. Hello. Yeah.
Yes, ma'am.
Okay. Yeah. So where were we? Okay. So the task is given to three students. Okay. Then find the probability. Okay. This will be multiplied. Sorry. So this is 1 by 2. 21 is 21 divided by
64.
So to complete it will be 1 minus 21 by 64, which is equals to minus 21,
43 by 64.
43 by 64. Okay. So this is the probability that the task is completed. Is this thing clear?
Yes, ma'am.
Ma'am, one thing I cannot understand. This is okay, like I understand that none of them complete, and then like we do that one, like. But one thing I cannot understand, why can't we do it like this? That like one person completes, other two do not complete, plus the second one complete, other two do not complete, and then add the three cases. That way we
No,
get
but why?
wrong.
No. The thing is, you are saying that Riddhi completes, then the other two are not completing, correct?
Yeah, yeah.
You are
Yes.
just adding that condition in which in each of the cases only one is completing, right?
Okay.
What about
Yes.
that all the three gets three completed? Then we can also say that RNS completes, P does not complete, or the other two completes it, something like that. So we can have different kind of situations. So you have to add all of these, na?
Okay. Okay. Yes, ma'am. If the question
You have,
have been like only one completes, then we would have done this thing, right?
Uh-huh.
you have to see in which way the cases are minimized.
Hmm.
When you start, just make sure that you can take either with complement if the cases are minimum, go that way. If by direct this you're getting less cases, go that way.
Okay.
See,
Understood.
the
Thank
main
you.
thing is in the exam the time is less, right? So just approach the way in which like it takes less time.
Okay, ma'am. Thank you, ma'am.
Okay. Okay. Any other question?
Ma'am, I have one question, but it's out of the questions that we have done in the activity and PYQ. If you want, I can ask.
It's other than PYQ. You are saying that?
Yeah, I was going through some previous papers, so I found one question.
Uh-huh.
Just wanted to
Okay.
understand.
Yeah, I can go through that, but the thing is, I need to make sure that nobody's having any doubts in this. Okay, nobody's
Yeah, no problem. We
speaking.
can do
Okay.
it in the end also.
If nobody's speaking, then you can go ahead.
Okay. Yeah,
Yeah, you go ahead because
I'll wait
nobody's
for.
speaking. Yeah.
Okay. The question was, there is a round table and one of the position is fixed for a particular person, and there are total 7 people. So in how many ways can the seating be arranged? One person has a fixed spot. I mean, the chair and the position is fixed, and there are 6 more people. So what is the number of ways for the arrangement?
So in total, we have seven, now.
Yes.
7 people are there, right? So if you remember in the
Yes.
circular permutation, the thing is that one person is already fixed and the other person are like they are arranged, they are getting arranged, right? If you remember the circular permutation, right? So in that sense, in the
Yes.
circular permutation, we had n minus 1 factorial, correct?
Yes.
Yeah. So this will be what?
Yes.
6 factorial only, because one person is already fixed. So six people are left. So 6 factorial. 6 people are going to be arranged in the in a circular way. Yes or no?
Yes.
Yeah. So this will be what? 6 factorial only.
Okay.
Yeah.
Okay.
I think
Ma'am,
this
but
is from which term?
we
I
have
guess
learned the
in
formula, right?
Jan
N
term.
minus 1
Huh?
factorial.
Sorry.
Ma'am, but like we learned the formula n minus 1 factorial, right? For circular
So
permutations.
for n is here it's 7, na?
One people is seated, like,
In circular permutation, what we are doing, we are keeping one person as a fixed. We are just fixing one person and we are just moving the other 6 persons here. That is the meaning of circular permutation. Yes or no? If you remember.
yes, ma'am.
है ना?
That's why
So
we do
same way,
minus 1.
they have just said that we have 7 people and one person is already fixed. Then what is the question? What is the other remaining arrangement? Something like that, right? How
Yes,
can
you
you
have to
arrange the
arrange the
other
remaining
people? Yeah, in
people.
the same way. So we in that example, if you remember, we had A, B, C, D, and in that we have just fixed one person and the other person are being arranged. So the formula got n minus 1 factorial. In the similar way, we have 7 people. One person is already fixed. So total remaining 6 people are to be arranged. In the sense, they are saying that 6 factorial ways we have to arrange them. Okay.
Oh, okay, ma'am, got it. The remaining ones we are like
Ah,
sitting under.
they have just explained it.
Okay, yeah.
Yeah. Okay.
Can
Anything else?
you discuss the questions of weekly mock for week 5 and 6?
Weekly map. Yeah, I can discuss.
The deadline
Okay.
is
Before that, our deadline is over, no?
yes.
Not over. Deadline is over. Okay. There was one question, and okay, I'll just discuss this thing because in that previous section, I just told you that I will be discussing this. So, is that person till now here or not? Still, he is not here. Okay. Do you guys remember this question? Question from graded assignment 7, question number
Yes, yes.
question number 4. This question, do you guys remember?
Yes, ma'am.
Yeah. Is there any confusion? Do you want me to tell you, like, explain this or no? If not needed, I won't be explaining. Is it needed?
Ma'am, which question is this? Sorry.
Question number 4.
The table tennis one.
Ha, ha, ha. If it's needed, then I will just go through it. If not, then I will proceed with the weekly mock 5 and 6.
Ma'am, this question was discussed by the TAs as we asked them also. They told that the sir told that he will tell us, so he told us. Look, it's clear now.
Oh, it's clear. Okay. Okay then. So, okay,
I
weekly
have a
mock.
doubt. I have
Huh?
pasted my
Huh?
question in comment in chat section. I have pasted my question.
In the chat.
Ma'am, you said grade assignment like week 7, question number 4, right?
Huh?
No, ma'am, it's like clear.
Huh?
It's clear. Like,
Ha, ha. Okay. No, no. One person had a doubt in this in previous section. So I told him that I will be telling you this in the next session.
oh, okay, okay, ma'am. Is there one? Seven people. The numbers. 50, 4 members. What are the digits? Can you tell me the digits?
0, 1, 2, 3, 4, 5, 6.
1, 2, 3, 4, 5, 6, 7, 7, using the capital letter to the first position. As you know, this is for the people. Okay, so there are one, two, three, four, five, six positions are there. In the third position, we have capital letter, right? So in short, we have 26 letters, right? So in 26 ways, I can fill this place,
Hmm.
correct? Now, the first
Yeah.
thing is we can't, as is zero can be included. Roll number, right? So we can have zero as well. Roll number. Okay. So in this place, we have how many numbers we have? We have seven total, right? Seven numbers we have. So this will be filled with seven ways. Similarly, now
मैम
one,
मेरा मेन डाउट यही है कि फर्स्ट पोजीशन पे हम 7 कैसे ले सकते हैं, क्योंकि फर्स्ट पोजीशन पे हम 0 को इंक्लूड नहीं कर सकते ना, क्योंकि वो
but
फिर डिजिट नहीं
one
माना
thing is,
जाएगा.
in the roll number we can have like it's a roll number, right? It's not a number. See, if they are talking about some numbers, then zero can't be like zero. If they are saying that we need five-digit number, okay, and these are my
Because of
numbers
the
from
alphabet, it becomes a string. If
so
it were
this
all
is not
digits,
a
then it's a number.
correct. So we are not making any digit like a number something, right? We are just making a roll number. So roll number can start with zero. Fine. Got my
Okay,
point.
then it's yeah, ma'am.
So this will be 7 into 6 into 5 into 4 into 3. So if you solve this, you will get some answer.
Ma'am, in these type of questions, we have to do this same way, or can we do that like selection of the digits from these like 7C5?
7, 3, 5. See, the main thing is no repetition is there. So
No,
you have to
means 7C5 into like 5 factorial.
7, 3, 5 into 5 factorial. Same thing, na? This is permutation only, na?
Yeah, yeah.
If you do
7C5 into 26 हो सकता है.
it will take you a long time to calculate. Just
Right.
do multiplication, it's faster.
See, the main thing is they have told you this is my format of the roll number. From these digits, I have to make it. So the main what you will do, just go through. That is what I'm saying. See, just go through simpler ways. Don't make it too complicated. You know formulas and everything. Just try to make it simpler, right? So we have five spaces, right? The third space should be filled with the capital letter. So there are 26 ways. Then the other four are to be filled with the numbers. We have these kind of numbers. Now, what in how many ways I can fill these numbers? That's it. Just make it in a simple, in an easy way. Okay.
Okay, ma'am.
Ma'am, I have a doubt.
Huh.
In week 7, graded assignment, question number 11.
Week 7, graded assignment.
Question number 11.
Unknown contains three balls. The coefficient of equation this is determined by drawing the number of balls. Statistics have margin. That is one.
The quadratic equation, no?
Sorry.
The question with the quadratic equation.
The quadratic equation.
You need to find the imaginary roots.
Yeah, that is what the probability
the
of
values.
imaginary roots. The probability.
Values of A, B, and C from 1, 2, and 3 that make it imaginary. In there you
Sorry?
get 4 cases where they're imaginary. You have to B square has to be less than 4AC. So the values
That
for
is what.
which
So my D should
B
be
and AC.
that it should be less than 0. B square minus 4AC should be less than 0.
Yeah. You can also do B square is less than 4AC.
So B square minus 4AC. So we have one. Okay. So let's count the probability of getting a real roots. What is the probability of getting a real root? It should be that my B square minus 4AC should be greater than 3.
You'll have more cases for real roots. If you calculate imaginary, you will get less.
For imagine,
Where will it become imaginary? So those are, I think, 4 cases you will have.
there will be only 4 cases.
Yes, for imaginary, there will be only 4 cases.
Like, I think for imaginary it should be greater, like it should be more cases, right? We will be having
Yeah,
more
sorry,
cases.
other way around. Yeah.
That is what, no?
Calculate real, yes. Yeah.
So for the real case only, we will be having few number of cases. So in short, let's suppose my P is like, let's suppose my P is 1. Okay. So that means this is actually what my Q square minus 4PC is greater than 0. If my P is
For
1,
P, it will always be imaginary because of the 4.
Huh?
If P is 1, minus 4 will always become negative for any value of AC. So P
so
for
it
all
will
values
be,
of P is imaginary.
So if this should
To
be,
check
if
only
my
2
P,
and 3.
sorry,
No,
once
we
again,
can
what?
because like 1, 2, and 3 is needed, na?
And we can also do one thing. We can fix B, like B equal to 1, and check the cases for A and C. And then we can easily get for like B equal to 1, B equal to 2, B equal to 3. And we get values for AC and count those cases.
Make the cases with P because that way it's easier to evaluate.
Just wait a minute. The other one has. So Q if my
If Q is 1, then all options become imaginary.
Q is 1, so this will be imaginary, right? So we want only real
Yes.
roots for that. So we will be taking those cases na, in which I have the real roots.
Yes. Correct.
Correct. So if my Q is equals to 1, then my P, so C, okay, my C values are also there, na?
Yeah, but that's what for any value,
Real.
the negative part is bigger. So it will
Yeah, so
always
that
be
is what.
negative.
So if my Q is 1, so
There are
1
no real roots
should
with
be,
Q as 1.
there are no real roots, na? Correct. Yeah. Okay, fine.
For Q2, I think there is 1 or 2. Yeah,
Q1.
2, 1,
Okay,
1
so
is there.
Q1 is not there, then we have Q2. If it's Q is 2, that is 4. So we can have, yeah, so we can have cases, right?
Yes.
So we can have for Q2 and then we can have for Q3 as well.
Yes.
So in short, we have 2 cases here. Similarly, if we consider for P equals to 2,
No, we don't need to do P then. These are the only options.
P equals to 1,
Ma'am, 3 into 3 into 3, 27 possible
Options for
equations.
P are already covered in the Q.
P, P, 1, P, 1, 2, 3. P is 1. Okay, which is 3, 7 minus 4 is there, right? And again, it's 2, 1, 1. Getting for the 2, plus 2, 2, 2, 1. Okay, so we can make, okay, in a simpler way, we can have C, C, we can have this minus 2, 2, 2, so minus 2, 2, 2, 2, then okay. So these are my cases, right? So there are in total 4 cases in total, in
Yes.
which I can have real roots, right? Okay,
Yes.
so the probability of getting real roots is actually what? 4 by 27. So probability of getting imaginary will be 1 minus 4 by 27, which is equals to 27 minus 4 by 27, which is 23 by 27. So this is the probability of getting imaginary roots, which is 23 by 27.
Ma'am, can you explain that table that you just drew? PC, PC1.
We are just taking this equation, huh? Q square minus 4pc. Okay. So I'm just taking one value. Okay, just ignore this for one. So this is my p. So I'm taking p value as 1. So my NC is also 1. So my PC will be 1. So this is actually what? 4PC. So if my PC is 1, so this will be what? 4. And I have an equation. I need real roots. So that means my Q square minus 4PC should be greater than 0. So if my Q is 1, then my 1 is 1 is less than 4PC, right? If I take the value of PC as 1.
Yes, correct.
right? So at that moment, my q square minus 4pc will be less than 0, right? It should be it will be negative, correct?
Yes, correct.
Right? So that's why in cases for which what cases I can have greater than 0 when q is 2 and 3.
Okay, got it. Yeah.
Similarly, the all other cases.
Okay, got it. Got it.
So
Thank you.
this is actually 4pc and this is my q values of q, and we have to make sure that my q square is like it should be greater than 4pc. We have to make sure this thing. Okay?
Okay, ma'am, got it. Thank you.
Ma'am, the same graded assignment of week 7, the first question.
This total time between arrangement. Mhm. Okay. So, arrangement. This is
You can fix the combination of girls and boys and then make the arrangement, and the 4 boys can be rearranged.
that
4
is what.
factorial is
So in short, like the first thing is if we have we will be having cases, right? So this is my first case in which my girl is in the first place and the second girl is in sixth place, right? So then how many ways I can arrange 4 boys in between? We can have 2 ways. We can have 2 ways. Now for the second case, the girl is at the second place and the seventh place. Then also we can have 2 ways. Then at third position, this is the third and eighth place. Then at the
We
fourth,
can group them as one group. That way it's faster. Girl, boy, the combination as one group. So the remaining boys will be 8. Sorry, how many?
girl, boy, no,
Okay.
what?
The 6 people, right? Girl, boy, 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 girl. That becomes one group,
Okay.
right? And then the remaining boys will be 9. The entire thing is 10. So rearrange 10 in different combinations, different arrangements.
Okay, then you will be arranging this one also, right?
Yeah. So that we will get the layout, and then the girls can be arranged in 2 ways. Boys can be arranged in 4 factorials.
We can also do that in that way also. We can do in this, like we can have the cases, like the third and the fourth place. Then this
Yeah,
will be the
you'll get
ninth
the same, but
place.
just take more
Same
time
thing
to do
only.
it. That's
Fifth,
all.
then,
Yeah.
uh, then if it's 6. We can have different cases. So in short, we have to consider. So we will be having how many? So for all of the cases, we can have 6 cases, which is 6, then 11, then we have 7, 12, then we have 8, 13, then we have 9, 14, and then we have 10. So in short, how many cases we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in total, I'm having 10 cases. Into for all of these cases, there are 2 ways. So it will be 2 into 10, which is 20, right? So I have 20 ways to this. So the probability will be 20, 10. Okay, so if you solve this, you will get some answer. Okay,
Okay,
so
ma'am.
basically what we are doing, there are 13 boys and 2 girls, okay? And the question they say is that we have to like put them in a line such that like 4 boys should be included between 2 girls. Okay, so in short, how many places do I have? There are 13 boys and 2 girls. In short, I have 15 places, right? So first of all, I would be arranging these 2 girls in any of the 15 places, right? So arranging the girls will be 15p2. Yes or no?
Yes, ma'am.
Yeah. Okay. Now we will be taking like we will be taking conditions in such a way that the boys should be like 4 boys should be between the 2 girls. Okay. So we have the first case is first girl is between the first girl is in the first place and the second girl is in the 6th place. Similarly, we will have the second place, then the 7th place, and all such that. Okay. And in each of the cases, there are 2 ways to do that, to arrange the boys and all. Yes or no?
Yes, ma'am.
Okay. So in short, how many cases I have? I have 10 cases here. Yes.
Yes, ma'am.
There are 10 cases. Okay. So in 10 cases, each of the 10 cases, there are 2 ways to arrange them. So it will be 2 into 10, which is 20.
Yes.
Okay. Now, the probability, we need to calculate the probability that there are exactly 4 boys between the 2 girls. So it will be what? 20 divided by 15p2.
Yes, ma'am.
Okay. Yeah, that was the question. And in the easy way, if you just look it into the other way, there will be 2 girls, we are arranging them. Then let's suppose from 13, 20, and then we have it. 15, 15. So if you just do it in another way, let's suppose this is- so first of all, the first thing is we are arranging the girls. In 15, 20 ways. Then the second thing is first we are choosing 4 boys. Okay, 4 boys we are choosing. Okay, so in how many ways we can do it? We can do it 13, 3, 4. Then we are arranging them, which is 4 factorial. So this will be So in total, we have 15 P2 into 13 C4 into 4 factorial. We're arranging them. Okay, just consider this case only, huh? Is this step clear? Is this question clear? The solution is clear? This
Yes,
method,
ma'am.
okay? Okay, any other question?
Graded assignment, that one question, fourth number,
Huh?
7.
Once again.
Graded assignment, week 7, fourth number question. You say you will discuss next time, next session.
Table tennis one, ma'am. I think he's the student.
Yes, yes. Table tennis.
Okay.
You say we'll discuss in next session.
So in the number of students. Okay, so in total, I have 220 students here, okay, who are part of badminton, table tennis, and tennis team, of which 50% are students play table tennis. So I have 50% who plays table tennis. Then we have 30% who plays tennis. Then we have 60% who plays badminton. It is also noticed that who play tennis also play table tennis, but not badminton. Okay, let's suppose we are making this sample space, the Venn diagram. Okay, so now this thing is this whole thing. This is, let's suppose this is my table tennis, and this the whole thing is my badminton. Fine. Now the thing is, they are saying that all the students who play tennis also play table tennis, right? So in short, I have 30% who play tennis, right? So this tennis people will be in this table tennis circle, yes or no? This is like 30%. These are 50%, and this is 60%. And this whole thing is actually what? My the sample space, which is 220 students. This whole thing will be considered that there are 220 students. This thing is clear? This Venn diagram is clear?
Yeah.
Okay. Now the question they are asking is, we need to find out the people who are there only in table tennis. Okay. So if I make so in short, we need this area. Right? Okay. Now, okay. So the first thing is we need to find out this thing. This, how many percent is this thing? If you know from the set theory, okay, this whole thing is like 100%. This whole thing, 100%. Yes or no?
Yes.
Okay. So that means my 50% plus 60%. Huh. So that means, okay. So 50 plus 60 is actually what? So this whole is actually my 100%, but this total is actually what? 50 plus 60 is actually what? 110%. If we need to find out this area, which is the intersection part, it is basically what? 110 minus 100%. Yes or no? Which is
Yes.
actually the 10%. Yes?
Yes.
Okay. So now I've got the intersection part, which is actually including the table tennis and the badminton player, right?
Right.
Okay. Now we need to find out this area. So basically this will be what? So in total, my table tennis is actually, okay. So in short, we have table tennis total is 50%. Okay. So that means, so it will be 30% plus 10% plus the remaining part equals to 50%. So this is 40% plus the remaining, which is 50%. So remaining will be 50 minus 40, which is 10%, right? So this is the remaining area. So my remaining area is actually what? 10%. This is my 10%. Yes or no? Yes or no? Is he here or gone?
Not sure.
What was his name? Um, are you there? Should I continue? Okay, let's. So this is R is 10%. So the probability will be what? 0.1. So that was the question. If he is not there, then okay, fine. Has he joined again? Okay, let's move then. Okay, so this thing is clear. Any other question? Any other questions? That's it. At least say yes or no.
Please, ma'am.
No. Yes. No. Do you have any questions?
No.
No, right? Okay. Okay, fine then. So that's it then. Shall we end the meet then? If you guys don't have any doubts. Shall we end the meet?
Yes.
Yes? Okay then. Okay, bye everyone. Have a great night. Okay then.
Ma'am, I have a question.
Yes.
So in quiz 2, is it like from week 1 to week 8?
No, 5 to 8.
Okay, thank you.